So proportions to solve. You're going to cross multiply. I think actually I'm going to do an example of sort of a trickier one. Let's say you have 4/7 equals 6/x plus 4. Okay? What do I do to solve this? Okay, so I need to do 4 times x plus 4, but how am I going to write that? Do I just do this? Do I just do this? Is this what I want to do? I want to take 4 times x and then add 4? I want to multiply 4 by this whole thing. What can I do to this to make it so I'm multiplying it by the whole thing? Nope. Because I want to multiply. If you say 4x plus 4, you're only multiplying the x by the 4. I want to multiply the whole thing. Ian, what do you think? Okay, so what I would actually do is I would write this in parentheses like this, and then I heard it from both of you. You're right. You would have to multiply the 4 by both of those things. But I would just write it in parentheses for yourself, and then you're going to remember to do the distributive property. And then over here I would do 7 times 6, which is 42. Let's distribute the 4. So that's going to be 4x plus 16 equals 42. And then what would I do to solve from there?
4
minus 16, yep. And that would be 26, I believe. Divide by 4, and I believe I'll get 6.5 for my answer. Okay, so that was one of the harder proportions problems. The other thing that went along with proportions was similar triangles. What does similar mean? Okay, but mathematically, similar means, let's back up and start with congruent. What'd you say? Okay, in general, yes. Mathematically, what does it mean for two things to be similar? Mathematically. Okay.
What's the difference?
Can I what? Move it up, sure. What does it mean for two triangles to be congruent?
Equal to each other.
Okay, so all of their side lengths are equal, and they're the same shape, right? That's what it means to be congruent. What does it mean to be, so congruent is same size, same shape. Similar means same shape, but different side lengths, different sizes. Okay, similar triangles have congruent angles. The angles are the same. But the side lengths are not the same, but they are proportional. That's why they're in this chapter. Okay, congruent angles and proportional sides. And you had 3 triangle similarity theorems. Your 3 triangle similarity theorems were AA, similarity, SSS, similarity, and then SAS, similarity. Okay, so these were your 3 similarity theorems. And in these theorems, remember, when you're talking about angles, like angle, you want the angles to be congruent. But if you're talking about the sides, you want them to be proportional. And so what you would do with the sides is check to see that they make a proportion. I'm just going to make up a set. Like if you had 3 and 6 and 4 and 8. How do you check to see if that's a proportion? How so?
Times 8 and 6 times 4.
There you go. So
8
cross
equals
multiply.
24, so they are
Okay? So 3 times 8 is 24. 6 times 4 is 24. So if these were your side lengths, you would say, yes, those are proportional. Okay? I think that's enough to get you started for today.
Yeah.